Greetings, Kerbonauts. This is Kerbal Space Program. I'm Bob Fitch, and this is a real solar system launch of a space shuttle. So hold on to your speakers, because these boosters are loud. Alright, that's a little bit better, so now I can introduce you to this particular episode. It's not really an episode of anything. This is just, once again, I am messing around in real solar system. If you remember my last real solar system, or my last really real solar system launch, and if you saw it, then you know what I'm talking about. I launched the Zarya module, which was the first one of the International Space Station. It went up on the Proton K rocket. This one, however, is the Space Shuttle Endeavour. It was launched in December of 1998. STS-88 brought up the Unity or Node 1 module to the International Space Station, or what will become the ISS, since at that point it was just the FGB, or the otherwise known as the Zarya module, that had been launched by the Russians. This first American launch also brought with it the PMA number 1 and PMA number 2. PMAs are pressurized mating adapters, and those go on either end of the Unity module and allow for the connections between other parts of the station. They can be detached and moved around, and in the years following this, they will be. Now I'm pulling up my Ferrum Aerospace window there to double check and make sure that I've actually gone through max Q, which is maximum aerodynamic pressure on the rocket launch here, and it looked like we had, so I closed that Ferrum Aerospace window back down again and continued with the launch. Speaking of which, because this is real solar system, technically I could speed everything up and make it look like it was practically a regular Kerbin launch, and completely gloss over the fact that these are very long launches. They take as long to launch in KSP under real solar system as they do in real life, which can be more than 10 minutes in some cases. But I'm not going to do that, because I think that defeats the purpose. What's the point of launching in real solar system if you don't get to show the grand scale of exactly how big things are, how slow it is getting things up there? And yet, when I say slow, I really mean fast, because we will be going 3 times as fast as we would be going, more than 3 times as fast as we would be going had this been a regular Kerbin launch. Now we've lost our little boosters there, and those are using the exact same specifications that would get used by a launch in the actual case of the space shuttle. STS-88 had a flight profile on those boosters that I simulated in this particular launch. What exactly does that mean? Well, the way that the real boosters work is they have a pattern on the inside. There's a cut. It's a little hard to describe, but basically imagine this star-shaped pattern that runs down through the middle where there's actually no fuel, and as they burn, the exhaust goes down through the center and comes out the bottom. And the way that they cut those on the inside, it allows the booster to actually essentially change the amount of thrust over time that's coming out. And so at the very beginning, there's only about 12,000 kilonewtons of thrust, which then ramps its way up to about 14,000, maybe a little bit more, and then it eases off. They cut back considerably when it gets to max Q, and then it powers back up again, and they don't have to do anything. They're not being throttled. The boosters are just cut internally to do that all by themselves. Now, of course, no launch goes completely without a hitch and works on the first try, so check this out. This is what it looked like when I was trying out this rocket for the very, very, very first time. everything was way too loose. I tried putting on there the stock thing, well, not stock, but so I'm using the component space shuttle. Ooh, nice big huge gas cloud there too. I'm using the component space shuttle, and that means that there's a bunch of parts that come with it, and I tried using one of those parts, which is the little strap-on booster radial decoupler things. Well, they were not holding on it very well at all. At this point, I was just trying to see how well they would hold on, actually. You can see I don't even have the nose cones on there, on those boosters. The nose cones aren't on because I'm not even remotely believing that this is close to actually launching. Not to mention I don't even have a payload in there yet. I just wanted to see what would happen, and boy did I find out. Yeah, okay. That's not exactly how I'm going to want this launch to go. I don't know about you. Anyway, just like I did with my last launch, the Zarya launch, let's go down into the VAB here and take a look at how massive this thing is. We'll scroll down into it a little bit here, and then I'll show you some of the components a little bit at a time. So since the first thing that has decoupled, I guess actually I should say, is these boosters. We'll start with these, and then we'll go back out and watch a little launch, and then come back in and see the next part, and we'll work our way through everything. So of course, the first thing that actually happened was the crew had made their way across this gantry and into the shuttle, at which point that ramp pulled itself back before the launch. Then we throttled up these engines down here, and all at the same time decoupled these and activated these solid boosters that are on the sides here. The majority of the thrust actually comes from these solid boosters. Those were sitting on a couple decouplers there as well, launch clamps that came from the FASA pack. The rest of it though, most of it, all the actual shuttle stuff, most of that actually comes just from the component space shuttle mod. Except for those clamps right in there, you can see those. I got those out of AIES because the ones that were coming from the component space shuttle mod were not actually holding it on very strongly, so I used those. Another thing I did was I threw on a little invisible from the B9 pack, this little strut right here and a strut right there, and that helped hold everything together for the launch. If we work our way up here, we can see that this is made of a nose cone that simply throws a little bit of thrust off toward the middle here as it goes to decouple, which allows it to push those away. Down on the bottom there, from the component space shuttle pack, there are some other thrusters that also help when these things are getting thrown away from the shuttle and help take them clean away and not let it collide with anything, hopefully. And then there's these themselves, and once we take those off, you can see that the mass drops considerably because a good portion of the mass that goes into this whole thing is actually coming from the solid fuel in those, since most of the thrust is coming from that solid fuel. If we take those off, now we're down to where we are in orbit right now. However, I mentioned that those solid boosters were using that special profile for how the thrust ramps up. Why don't we take a look here for 1 second at this chart? This is what I used to figure out what level of thrust I was going to have at each point along the way. And instead of using mission elapsed time, what I did was I figured out with a spreadsheet exactly how much fuel was still going to be in the booster. Now that's not the exact same data that I used, it's the same sheet, and I wasn't thinking about it, and in order to, for Project Odyssey, make another booster that was very similar to the one in Real Solar System, I used the same spreadsheet, but I changed all the numbers, and then I took the numbers and I moved them over, and then it was too late, and I shouldn't have done that before I took my screenshot, but oh well, you get the idea. You can see that basically I laid it out here, where every second a certain mass of fuel is being burned away, and that's changing its altitude, it's changing, which changes the ISP, it changes the thrust based on the percentage that I've picked down the middle, and the wet mass, dry mass, how much delta V, what's the thrust to weight, and that whole thing is trying to keep the thrust to weight for the entire launch at a nice set level. I think it's somewhere around 2.5 times gravity. So with that data, I created my own CSS's SRB part override module with the module manager file here, basically. So you can see where I'm changing the rescale factor back to equal to 1 so that it scales up to the original size, which is appropriately sized for real solar system. Set the mass back to 88 tons when there's nothing in it whatsoever. Put over 280,000 liters of solid fuel in it and set the appropriate ISPs for both sea level and vacuum. And then we get to the good part. If we scroll down here a little bit, this is how the thrust curve gets set. That thrust curve segment in there that says key equals over and over again, the left-hand value is the amount of fuel that's remaining because I'm using thrust curve with the use time curve equals false just up there in the middle. And then the right-hand value is the amount of thrust. And so you can see how it scales itself up from, well, actually start from the bottom. You can see where it scales itself up from 0.89, which is 89%. It goes up to 98% once it has 79% of its original fuel remaining. And then it throttles down. You can see it goes to 71 at 49% fuel. That's max Q, because then after that, it throttles itself back up again to 75. But then because the fuel is draining out of it and the thrust to weight would go way, way up if the thrust stayed the same while the mass went down, it begins throttling back, but only to maintain that nice easy thrust to weight ratio. So down to 79, 78, 70, 62, 51. And when it's down to its last 2%, it throttles way back. So the boosters look like they're still burning when they decouple, but they're not really generating a lot of thrust. So instead, all they do is sort of go off to the sides and then fall away with very little thrust coming out actually at that point. Back here, you can see our current altitude is 96, 97 kilometers, and we are still rising. I'm shifting the shuttle over to put it on the proper trajectory to get its inclination set correctly to the Zarya module that's already in orbit. We're trying to rendezvous with it, of course, and because I'm trying to not spend forever on this, I also don't want to do it quite exactly the same way that the real one would have gone, which is basically to say that they would have taken more time than I'm going to take. I would rather just get up there, get it docked, not spend 5 days trying to actually get close to the thing. I don't remember exactly how many, I'm exaggerating, it's not 5 days that they take to get there, but typically the shuttle will take a couple days to rendezvous with whatever it's trying to get to. Me, I'd rather go directly from the surface right to the target and rendezvous within just minutes. In fact, last time when I was launching something, I didn't need any of that rendezvous information in my MechJeb's flight computer window, so I just finished adding it. Now I have in there my close approach distance, my relative velocity at closest approach, and my time to closest approach. And that's allowing me to keep track without looking out at the map. It's allowing me to keep track of how long it's going to be and how close I'm getting. So that's what I'm watching right now, is I'm keeping my trajectory going toward that 51.6 degrees because I know that I launched right under the orbit of the Zarya module. So as long as I'm following on that, as well as looking down at the bottom at that close approach distance, which you can see is getting pretty good now. It's coming down into the less than a few million meters and still dropping. So as long as it's dropping, I'm happy with it. We've been burning quite a bit of liquid oxygen and liquid hydrogen coming out of that big orange tank there in order to get ourselves up to this orbital velocity that we need, but we are getting really, really close to it now. Pretty soon we'll run out and we'll decouple that orange tank and let it go back down and be destroyed in the atmosphere. However, let's first go back and take a look at some of the other failures I was having. So if you remember, we had just switched out the decouplers because we knew that, oh boy, well, stuff is still getting stuck. We knew that we needed to get rid of those ones that had been coming from the component space shuttle mod there. However, things still aren't quite kosher. Placement of the launch clamps is very, very important. That's why ultimately what I had decided on was just having that one. Oh, there goes that smoke again. Something's up with that smoke. It really loves to fill the screen and lag things up. Anyway, I was saying I had decided on having just the one gantry as well as the 2 clamps on the sides of the booster and let them rest on those FASA launch clamps way down at the bottom. Next up, what we have is the Space Shuttle's external tank. It is hooked on, technically it's hooked on down here, although in KSP, of course, you can't actually attach things without docking in more than one location, and the way that this is hooked on in KSP is up here at the nose. So in order to make it look more like it's supposed to, where it's not flopping completely around, I put a couple struts, invisible struts, from the B9 pack down here. But what's supposed to happen is it attaches in the real case through these fuel lines that go down in here and then fuel these 3 engines on the backside. Anyway, if we take a look over here, you can see that it has liquid hydrogen and liquid oxygen on the order of millions, hundreds of thousands, millions even of liters of those 2 types of fuels, 623 tons and 104 tons of oxygen and LH2 to supply those engines down there. So we'll just pop this off, and now we're down to the shuttle all by itself. And why don't I just start off by taking a look at the engines, since we've been using those and we're about to shut them down and make them not really part of the equation per se anymore. So those engines are the RS-25s, which I didn't rename them. Technically, that's not their name, but I did set all their specs to be appropriate. It's 3.177 tons with a 2278 max thrust. We have the ISPs set from 363 up to 453, and that's what they are in real life. This is the exact amount, I think, hopefully, I'm crossing my fingers, of how much it's using per second of fuel, and that is a lot, right? Look at that. 1,000 liters of liquid hydrogen, 480 liters of liquid oxygen per engine per second. Now, of course, that's going to change as in the real case, as it goes higher up. The thrust is going to be changing, the ISP is changing, but that's what it uses at sea level, and that's an awful lot right there. So I'll just pop these engines off, and that way that'll be one less thing to look at when we come back here next time. But for now, let's go back out to the launch for a little bit more look at what's going on there. And that's it. It's official. That thing has been run dry. So we have decoupled it and off it goes now. It's going to drop down into the atmosphere and ultimately burn up. Meanwhile, the shuttle thrusts away with its RCS up higher into a higher orbit, activating its orbital maneuvering system. You can see those engines are sputtering there. I have set up a little maneuver node to put me on the right path and get me over to that Zarya module so we can dock up to it. Now, in a real shuttle, there isn't a lot of delta V left over in its orbital maneuvering system. Once it drops that orange tank, it doesn't have more than a few hundred meters per second. Now, if I had been launching something at its maximum payload, which is more than double of what Unity is, I'd have only a few hundred, which would probably be used just for a tiny bit of orbital maneuvering, as well as then deorbiting later, which deorbiting takes 150 to 250 meters per second all by itself. Right here, I had more than 700 delta V though, only because Unity weighs only 11.6 tons, and that's what I've got simulated in here. So you can see we've opened up our cargo bays. That is opened up to make sure that we can radiate our excess heat out into space and not overheat down inside our cabin there with the sun beating down on us at times. Okay, well, with Unity now exposed to space, let's look in the VAB here and take a peek at what is inside that cargo bay up close. I attached this to the interior using an Infernal Robotics hinge and a little rotator here also from Infernal Robotics, which is then going down into a docking node that connects it to one of the PMAs. Now, what was supposed to happen, if this had been more realistic, is there'd be the robotic arms on the inside here, and the arm would reach out and grab onto a grapple fixture on Unity, lifting it up and attaching it here to this docking node inside the cargo bay. But instead, in order to make things just a little bit easier on myself, hold on, I'll come back to that in a second. Let me just show you this so I can take it away. To hold this steady for the launch, I put a strut on a decoupler in here. Anyway, I was going to say, to make things easier for me, what I've actually done is made it so that this Infernal Robotics hinge can rotate this up like that and make it sort of like it would be had it been moved by the robotic arm. It's a little bit robotic, right? That thing in there, it's robotic. I mean, it's not exactly the right thing, but still, trust me, it is way easier and less time consuming to do that than it is to make a real robotic arm that then has to jiggle all over the place at all of its joints and shake and shake and shake like this. Believe me, this is way easier. So it'll lift up real careful, and then this will decouple, and then I will just dock it right in there, and then we will go, well, it'll be rotated actually, because that's what that rotator in there is for. It'll rotate itself into the proper orientation, and then we'll dock it up. But anyway, it'll look like that when we're docking. Let's move this out of the way. Go away, Infernal Robotics. And so that's the payload. You can see that we have a PMA that comes from the community pack for the ISS construction, and so does this. This is the common berthing node, another one that's actually on the node itself, the node 1 Unity, a KW rocketry end cap, and all that is duplicated over here as well. We got some more lights on the outside of it, 8 lights just to light it up and make it look pretty in space. And then this piece in here is a LLL, Lackluster Labs, structural piece, just our 2.5 that I have scaled up to be the proper dimensions of the Unity module. Since we're using it right now, I'll take another quick look down here as well at the orbital maneuvering system. You can see those engines come from over here, the CSS, OMS, left engine, right engine, although I have modified them to use the MMH and N204 for their propellant. That propellant is stored in here. The MMH and N204 are in there in roughly similar liters, but that does not come out to the same mass because one of them is heavier than the other one is. Okay, I haven't had a good explosion in a while. You can see that when I was testing this, as I closed those cargo bays there, the payload was just a couple of modules that come out to 10 tons each, so 20 tons, and I just wanted to see how well it would do if it were lifting closer to its maximum load, since the Unity and its PMAs, it's not even close to 20 tons. But the problem isn't how well it's going to launch, it's how well it's going to stay together, because initially it just was shaking itself apart from the very beginning. And that turned out to be that I needed to make a couple changes to the parts, not dimensions, but the connection nodes. So in 0, 2, 3.5 of KSP, the connector nodes in between the different parts, whatever size they are, that helps the physics system understand how much strength there should be between the different parts. And some of my parts were still at the smaller sizes for normal KSP, not for scaled up real solar system. And so once those got fixed up, then it started to fly a little bit better. Not right there, that's still going down and exploding and flying into little pieces because it's having some trouble right now keeping itself oriented in the proper trajectory due to the gimbaling on the engines and its ability to go at the right amount. Real space shuttle engines have a tremendous amount of gimbal freedom there, and I had set mine a little bit too low. Once I got those set up higher, and also I was using that KM gimbal mod, that helped things quite a bit. Now right there, I was trying to speed up, and every time I did, it really dramatically changed how far away Zarya was supposedly from me. So instead, what I did was I just went at either normal speed, and then I'm speeding up the replay of the video here, or I sped up using physical time acceleration, which is you hold down the Alt key when you're going to do the comma or the minus in order to change your speed, and that physical acceleration then means that it keeps its orientation and its distances a little bit better. Okay, now it's finally time to do what I was talking about earlier, where we decouple that strut, and then I don't want this thing to shake a lot as I move that up, so I've set the hinge to 0.1, and this is how fast it was really moving. Now I'm going to speed up the video right here so that you can see it a little quicker, and look at that decoupler floating away there. Anyway, speeding it up here because you don't want to watch it at the normal speed. It went very, very slow. And then we're going to rotate it as well because I want to have it oriented towards Zarya correctly. We've done another 0.1 in that rotator for how fast it's going to move. This is how fast it's really rotating. But here in a second, we're going to speed it up to 10 times normal speed, and there we go. Now showing you as it rotates much quicker for the replay of the video here. We can get it into position, and then I will decouple it and shift down away with the space shuttle using its RCS thrusters there in the front and in the back, built directly into the parts that come with the component space shuttle pieces. You can see them powering up right there and moving me down and away. I've got my Navy fish docking alignment indicator in the bottom right, and I'm actually using that in order to go do the docking, but the parts that come with the PMA there, they also have a camera that was built into them, and I was trying to see what that looked like, and so that's why you see that one in the upper left, that APAS port camera. However, it's just a lot of white when I'm looking at it. So I focused on that Navy fish docking alignment indicator in the bottom right and not that APAS one in the upper left at all. It just wasn't showing me anything useful. So we get that docked up there, and now I'm going to shift myself over. Now here it's actually showing something in the camera in the upper left, but that must be because it's pointing now down toward Kerbal, where it's actually getting some nice contrast between the parts there. Well, while this is rotating into position, we'll go down here into the VAB and finish up in here, taking a look at the last little bits of what went into making this shuttle. So I've filtered it down to just the CSS parts. You can see them here now as I move through these tabs. These are all the parts that came with that, and I used all of those by scaling them up into the appropriate sizes in order to make them be the right size to be an exact replica of the dimensions of a real shuttle. In the front here, we have the forward RCS, which also operates on MMH and N204. All of that, of course, coming from down in here, which I showed you earlier. It has 9,000 liters of each. So that part fits right in there. Then we have the crew section, which comes from over here. That's actually my root part. I won't be able to remove that, but you can see that that contains in it. I put in it a nice 7 kilowatt hour battery, as well as a few liters of hydrogen and oxygen, which are used in the fuel cells. And those slowly generate water as well as power, and that power then powers the whole shuttle, while the water gets consumed by the crew. Also in there, you can see that that's where we have our docking port, which is right in there. We can also take these parts out. Those aren't really part of the shuttle. Those are my simulation of robotics. Underneath here, we have under the nose. Let's move down here where there it is. So there's the nose, and that one, its only purpose is to provide some heat shielding as well as a place to put one of those wheels. There's also wheels down here on the wings. The wings have control surfaces, of course, here and here. And while I'm pointing out the wings here, let me just say that getting this to fly in real solar system when it was originally not set up to do so was really hard, because I'm using Ferrum Aerospace and I needed to really tweak this thing to make these parts work in Ferrum. For example, one of the things I needed to do, let me just show you here. So this wing, it has a surface on it that somehow Ferrum is able to figure out how that surface works to provide lift. But the wing that was over here that normally came with the system, it was generating its lift on the wrong side. So when I would hook this one up on here like this, and then it would shift the center of lift way over here under the wing, putting this one on as well didn't actually change anything. The center of lift, if anything, it went further to the left because it thought that both wings were generating lift on the left-hand side. In order to get around that, what I needed to do, notice over here, this is not how the parts come in the component space shuttle system. This wing is actually the same orientation of the other one now because I flipped it. I flipped it so that in the VAB, then I could actually use the VAB to flip it so that when I attached it, it would generate its lift going out in this direction. I have no idea how actually Ferrum figures it out, but I at least was able to figure out that somehow that mattered, and I was able to get it to then move its center of lift to be underneath here. But there was a little bit of hackiness still going on, and I'll get to that in a minute when I show you this middle part right here, this cargo bay. Let me finish up with what we have not shown so far. So there's the control surface there, and that one in the back, and the engine bay. Take the wings off now, which does leave us at the cargo bay. And finally, the nose piece here, and this is the root part of it all. But if we take that away and I just put in the cargo bay, this is another thing I had to do to cheat Ferrum Aerospace into understanding where everything was supposed to have its center of lift in order to make it actually fly. Because I'm not really some super genius that knows how to make airplanes or anything. I just tweaked these values until they worked. Notice what I did there was I cheated basically, and I shifted the center of mass to be way underneath the cargo bay, and that caused my center of lift to be able to actually sit up and behind the center of mass, and that allowed it then to successfully land later once you get to that point in the video. But we can't land unless we've docked and released that payload. And even though it's a little bit unrealistic, I've decided that I'm actually going to dock from the Zarya side rather than the space shuttle. Once again, the reason not having anything to do with realism, because it's not, it's just because it's simpler that way. When you do a control from here from something that's going out radially from the direction that you're actually trying to travel, you can get weird things like this. This is what happens when you have it attached to an Infernal Robotics hinge and then you try to tell it to control from here. Now, I did this just as a demonstration to show you what it would look like because I already knew it was going to do this. I've had this happen to me in other games when I've played trying to do this similar sort of thing right here. Anyway, that's it. We have docked ourselves up. We've decoupled. We'll just slowly ease ourselves away right here. Take a little last look at the Zarya Unity combined module, the first two in the ISS. This puts us at December 6th, 1998. And we are ready now for the we're ready now for the Space Shuttle Endeavour. STS-88 is ready to go home. One more trip into the dark side of the planet, and then we'll be able to start our retro burn that'll bring us down into the atmosphere and hopefully land somewhere in North America. I'm not going to be able to target a specific location because I just have never done this before. I don't know exactly how long it's going to take to land. So I'm just going to kind of go around here a few times until we're sort of coming down in North America, and it's just going to land somewhere. We'll be happy as long as it's flat ground. That's as much as I'm looking for. If I were really following history, then I'd be landing at the Kennedy Center on runway 15 on December 16th, but for me this is actually just a little retro burn very shortly after, since Kerbin has completely different days anyway, and we're bringing down that periapsis. Now you can see it's going to be coming down somewhere over North America like I was hoping, and we'll just close up that cargo bay to make sure that it doesn't interfere with our ability to go through aerospace here. I don't know what that's going to be like. I see a little bit of reentry heating, but honestly it was a lot lower than I had expected it to be. I thought it was going to be much more difficult to maneuver. It's pretty difficult. I end up going sideways for just a little bit. As I understand it, maybe some degree of that is sort of how they slow down once they get lower. I don't think they're actually supposed to be turned like this at this point. Well, it's still doing all the reentry heating, but I just couldn't get it rotated quite right until after we had slowed down a little bit. Fortunately, nothing was burning up, so it looked like that heat shield that I added for deadly reentry was working properly. It did a little bit more reentry heating here, got a nice little orange glow to it. It didn't last for very long though. After that, I was going much slower, and I was able to right the craft and bring the nose back up again. Right through here though was maybe like, I don't know, maybe 30 seconds or so. I was afraid that it was going to flip out of control, but I was able to get it back under control, and then it slowed way down. Brought out that landing gear, and looking down I see that we are definitely coming down over some sort of flat-ish terrain. I figure, okay, this is it. Hopefully I'm not gonna screw up the landing, flare back a little bit at the last moment. A little bit of odd clipping with the shadow on the ground. I guess that's just an artifact of real solar system. Flare back again, and bam, it hits the ground. Safe and sound, come rolling to a stop, and that's going to do it. I'll see you later, Kerbinauts.